So you guys want to learn programming. I mean, that is why you took the course, right? But what exactly is programming?
I think everyone here knows what programming is. It's just writing code to make the computer run some programs, right?
Well, that's only a part of the answer. The bigger picture is to understand how that happens and why does it happen so smoothly.
How important is that for a programmer, especially a novice one, to know though?
Indeed, it is. Knowing the bigger picture not only makes you a better computer scientist, but also helps you write really efficient code, which is basically a requirement in all programming and development tasks. I mean, you cannot really expect to write long and complex code to do a task which can be done with a few lines of code and in a shorter amount of time. If you do this, your project manager is not going to be too happy with you. Let me tell you that. Even if you're developing your own application, writing inefficient code is just going to cost you longer runtimes, more errors, and, well, more security issues as well.
Well, I guess you do have a point, so go ahead, enlighten us, zap us with the lightning bolts of knowledge.
By now, we should be already knowing that there are overlaps between electrical engineering, computer engineering, and computer science. In this section, we will look into some of those overlaps in detail and discuss why they are so important. Let's start from electrical engineering. What is the one thing every electronic device requires?
Ooh, power. Ideally, hamster wheel power.
That's right. Every electronic device needs power, or what we call electricity, to run. Now, once this power is supplied, we have something known as transistors. In simple terms, they can be just considered as light switches in your house. They have two states, and they can either allow the supplied input current to pass through or not to pass through, which is when they will block them. They are basically made of semiconducting metals like silicon. Do you know, Jay, how many of these transistors are there in today's CPU?
I don't know, probably like in the thousands.
Not even close. We have hundreds of millions or even billions of these tiny switches in our modern CPUs.
Okay, that's a lot more than what I was thinking. Wow.
Indeed, it is. So, moving on from this, each of these transistors are combined into logic gates, which we call Boolean logic gates. Why are they called Boolean? Well, because they are based on Boolean algebra, introduced by a mathematician called George Boole. We are going to tackle the basics of Boolean algebra in the next section with Professor J. For now, these logic gates are capable of performing basic computation such as AND or NOT on electrical inputs. Combining multiple Boolean logic gates together, we get complex computational capabilities. And this is when we get the electrical circuits that you can find in today's CPU. Now, when I'm mentioning combining logic gates, what I mean is that we combine billions of transistors together to form a large amount of logic gates, which produces just one computational capable device. And this is known as our processor.
And I just feel like pieces of a vast computing puzzle just sort of clicked and fell into place. Things are way more direct than we initially think, is it not?
I hope it does. That's why I'm doing this. So the fact that our processor capability is increasing over the years, it has nothing to do with software or computer hardware, but everything to do with electrical engineering. Shocking, isn't it? This phenomenon is summarized by a theory known as Moore's law, which you can see in the chart. This law, by the co-founder of Intel, Gordon Moore, states that the number of transistors in a dense integrated circuit doubles every 2 years. This is related directly to electrical engineering, right? And production capabilities of these manufacturing industries rather than anything else. So the integrated circuit that is mentioned here is nothing but billions of these circuits, which we discussed, billions of these transistors, which we discussed earlier, brought together to form these circuits on a single thin board called a chip. This is also made of semiconductor like silicon. And
they're not made of tortilla chips or potato chips, just so you know.
Yeah. With that clarity in mind, that's basically it. That's all the electrifying knowledge you need at this stage. I mean, guys, at the end of the day, we are not here to produce silicon chips, are we? We will be doing something more relaxing, which is writing code and sitting on our chairs and listening to music. So let's move on to the next video where we go up to the next level and see CPUs in all of their glory.